All right, welcome everyone as we get to talk about sustainability meets velocity, the future of modern deployments with GitHub, Octopus Deploy, and Arm-based AWS Graviton. Now that's quite the mouthful. I understand it's a lot to take in, but we're really excited to be here today. Just a little bit of housekeeping before I dive into the webinar with our esteemed guests. First up, we're going to send out a recording after this webinar finishes up. I'll probably be out either later today or tomorrow. So don't worry about trying to frantically write down any sort of notes or anything like that. We'll have links to all of that going out. So thank you very much for joining us again today. So I'm excited to be here. And let me just say, we have an esteemed panel. We have a host of people coming in from all over the world. I'm going to be your host. I'm also going to be doing some demonstrations with Octopus Deploy. My name is Bob, but we also have Miranda joining us from AWS, Alexis joining us from GitHub, and Eric joining us from Arm itself. Thank you so much to the three of you for joining us. How's everyone doing today?
Fantastic.
Awesome.
Excellent.
Really well.
Good.
You're never quite sure of who's going to step over each other's toes when we start doing these group webinars like this. So I appreciate you being a little flexible. So I want to take a brief step back and talk a little bit about what we mean by modern deployment pipelines. So when we talk about a modern software delivery pipeline, there's going to be two things that we're really going to be focused in on. The first one is going to be a modern software delivery pipeline is really going to focus on best in breed tools. And so when we talk about best-in-breed tools, when you want to think about the best-in-breed CI service that's out there, you're going to think about GitHub and GitHub Actions. The best Git-hosted provider, that's going to be GitHub, obviously. When it comes to software delivery and continuous delivery, this is where Octopus Deploy is going to come in. And then Octopus Deploy is going to provide a number of different services in terms of enabling you to deploy your applications to various application hosts. But the most popular cloud-based application host, and again, talking about best in breed, is going to be AWS. And AWS has a host of different application hosts, be it Kubernetes, Lambdas, EC2s, ECS, RDS, anything in between. But the second part of a modern software delivery pipeline, this is going to focus in on what is the underlying infrastructure that's hosting your modern applications. And right now, you really have two choices. You have x86 and you have ARM. And so today we're going to talk quite extensively about the benefits of what ARM does, how you deploy, and how do you convert over for that. So in terms of what to expect for today, in terms of an outline, first, Miranda's going to talk to us about why ARM and AWS Graviton. Then I'm going to be talking to you about building applications for ARM, what it's like to deploy to AWS Graviton service, and then Alexis and Eric, they're going to wrap up with how to migrate your applications to ARM using GitHub Copilot and the Arm-based MCP. So I'm going to hand it over to Miranda, and she's going to talk to us about why ARM and AWS Graviton.
Thank you so much, Bob. And yeah, if you search for the word AWS Graviton, if you have never heard about it in Google, then the definition will be AWS Graviton is a family of processor designed to deliver the best price performance for your cloud workloads running in AWS EC2. Okay, that's really mouthful, and I was confused when I first read this sentence. What does this mean? So it tells two things. First, it's a CPU chip. It's just like any of the CPU chip running in your local PC, but it's designed specifically for data centers, for cloud workloads. And it works with Nitro system. So what is a Nitro system? Nitro system is essentially a hypervisor. Basically, it's responsible for, hey, in this little chip, which part is responsible for caching, which part is responsible for processing. Yeah, that's Graviton, and in this picture, you see a physical representative of the Graviton fourth generation, and this is what it looks like. From your end user perspective, you won't be able to see any of those when you're using them. So, okay, next slide, we're going to talk about why AWS Graviton. There are so many different chip brands already existed in this world, right? So, like you have Intel, you have AMD, and why you need AWS Graviton. So, because it's specifically designed for cloud workloads. So, in this cloud workloads, it's offer best price performance, and it costs up to 20% less than its apple-to-apple other type of EC2 instances. And most importantly, it delivers up to 60% less energy than the rest of the EC2 types. So it's also worth to mention that in all of the AWS points of presence, there are currently 28 countries' data centers are already using a complete renewable energies at the moment. Next slide. Yeah, just like any technology we deliver to our end users, we are always asking ourselves, okay, what does the end customer want? They obviously want things to run cheaper, faster, and more powerful, more efficient. So we come up with the idea each Graviton instance should improve based on what AWS learns from all of our customers in real life. Graviton 4 has already delivered up to 30% better performance than its last generation, Graviton 3, and support up to 192 CPUs for large database and analytical workloads we currently all need. But this actually introduced a new challenge, right? When you think of multiple processors or put together, 192 of CPUs all together in a little chip, little space of there, when you get more of those, accessing data across that connection might be slower. And in the next slide, I'm happy to introduce that in the last year reInvent 2025, we have released and announced AWS Graviton 5, and it's currently in preview today. So how does that different from the last generation, which is the first one? Is it's basically deliver the same number of core with improved L3 capacity. So basically, L3 capacity is a type of caching that can allow all those cores to access the data that's mostly accessed, most frequently accessed, closer to its physical location. So it's more efficient. And this is also our most efficient CPU ever existed on the market. So how do we use those AWS Graviton chips in the next slide? So if you look into your AWS account and you search for Amazon EC2, then you're going to see there are so many different types of EC2 instances. We call them instance family, right? And all the instance family names that has a suffix of little g over there, this basically means they are powered by Graviton chips. And you can find there are general purpose M7G, M8GD, and C7G. So all those are Graviton. And it's worth to mention that M9G is powered by AWS Graviton 5, and it's currently in preview in some of our regions. Feel free to have a try. Besides using the EC2 instances, how do you use Graviton instances in other type of services? Graviton is also supported by so many different AWS managed services, including the database services, your favorite DynamoDB, your favorite document DB, Elastic Cache, RDS. You can select the Graviton type of instances over there. Analytics workloads, compute as well. You can use Graviton for Lambda even. Those services making adopting the Graviton as easy as just switching from one instance type to another in the console or via CLI or via the infrastructure as code, which you will hear how it can get done in the later on in the session. So next, the easiest way to see the performance difference between your current workload versus what if we move to Graviton is to take a look at this Graviton savings dashboard. This is a free of charge, and it gives you the percentage of carbon savings assessment for your cloud workload migration from non-Graviton to Graviton instances. So yeah, and it looks like this on the right-hand side of the PowerPoint. So yeah, feel free to scan this QR code and get your own share of the how does the Graviton would look like in your cloud workload. Thank you. Over to you, Bob.
Thank you so much, Miranda. So yeah, so we've talked a little bit about what AWS Graviton was. I really appreciate that. I'll be completely honest. When I first started preparing for this webinar, I didn't know what AWS Graviton was. I mean, I knew what it was, but I thought it was another thing like AWS Lambda or AWS RDS or something like that. I didn't realize it was just a process, not just a processor family, but it was a processor family. It's like, oh, much easier for me to wrap my head around.
Yeah,
so
CPU
go ahead.
chip. Yeah.
Yes. Yeah. So I'm going to be talking to you about what it's like to build your code and deploy it. And I'm going to be deploying to an EKS cluster that is running on AWS Graviton. And so I first like to start out this presentation just with a brief understanding of who is responsible for what. So we have a kind of a very clear line of demarcation when it comes to GitHub and Octopus Deploy. So GitHub is really great for building your code, linting, static code analysis, vulnerability scanning, tracking known vulnerabilities, running your unit tests. And then if you want to get into supply chain security, it's really good at generating the SBOMs and those attestations. And once everything is done, you can then hand it over to Octopus Deploy. And then what we're going to provide for you is we're going to provide the capability for environmental progression and this single pane of glass. So you can not only just see your application, but any of the applications that you're responsible for, or if you're a platform engineer, all of the applications in your entire tool chain. On top of that, we're also going to provide fine-grained RBAC controls. So you can have scenarios like where devs can deploy to dev, but they can't deploy to production, for example. Or if they can deploy to production, you can require ITSM approvals. But then when you get into the actual deployments themselves, we can do a number of things besides just deploy. So we can do things like verifying your attestations or scanning the SBOMs to see if there's any new vulnerabilities since you last built your application. Any number of those different types of things are completely possible with Octopus. And the big reason why is because we, as a company, we're focused on continuous delivery all day, every day. That's all we think about. And the reason why that is because the complexity with your deployments often goes beyond kubectl apply or the AWS command to deploy to Lambda, for example, or running CloudFormation. Oftentimes you have these pre and post deployment steps that you need to worry about. You have to worry about day 2 operations, what's the status of your application, and anything else in between. And so at the end of the day, your deployment process could look fairly complex. And once you have that deployment process built, specifically if it's for a common application, one that deploys to the database, and then it also say deploys to EKS, you want to be able to scale that out. And so this is the other thing that Octopus Deploy provides is the ability to scale out that complexity to not just a couple teams, but to hundreds of teams. And if you ever need to make any sort of change, so for example, if you want to go from say x86 to ARM and there's any sort of changes you need to apply, we make it very easy to apply those changes across all of your deployment processes. All right, so I kind of provided a bit of an understanding of where GitHub and Octopus fits into your pipeline and why you'd want to use each one. Let's talk a little bit about what I had to change for this demonstration. And truth be told, I didn't have to change a whole lot. Now, granted, this was a containerized application, so it was it's a bit easier for me to do. But I think it really speaks to the maturity of where we're at today when it comes to switching to ARM. All I had to do, honestly, was I just had to change my actual what I'm building. And so I decided to say, I want to now build an ARM-based version of my container. Then I wanted to do that so I could have both an x86 and an ARM-based version, just in case if I needed to transition back for whatever reason. I had this nice, easy transition to kind of make that a smooth process as I get over to the new stuff. When it comes to my Docker file, I'll show you exactly what I had to change. There wasn't a whole lot. I just had to add a target platform in the build platform arguments. And then finally, I just needed to update my job. And this was really more for me to run on ARM64 runners in GitHub. I didn't have to do that step. It was just something that I wanted to do, just morbid curiosity more than anything else. Now, when it comes to the deployments within Octopus, to be honest, I didn't have to change anything. And this is primarily because Octopus, we've supported ARM for years. Especially when it comes to things like EC2 instances or EKS clusters or ECS clusters or say Lambdas or anything along those lines, we're very agnostic when it comes to that point. Now, it's not 100% smooth because sometimes there's going to be third-party tools. So for example, if I was using say Liquidbase or Flyaway or any of those third-party tools, they may or may not have an ARM-based version of their application. And so I might have to have a runner inside of Octopus that's still x86 to execute those things. So your mileage may vary, but overall, I don't really have to change anything. I'll walk you through what that looks like right now. So I'm going to jump over to a demo. So before I get into the demo, the very first thing that I want to do is I'm actually going to trigger an action to run so I can show you it deploying in real time. So it's going to take a couple seconds. All right. So I'm first going to start off with GitHub. I'm going to zoom in a bit just so we can see, we want to start from someplace. So I have just committed a change. And so I could see this now deploying. I can see it, building. So I have this build CI running and I wouldn't say it's a complex build, but it is doing a fair bit. I'm running my unit tests. I'm scanning my repo for any vulnerabilities, creating the GitHub release, creating the SBOM, actually building my Docker container, generating the attestations, and then I'm going to hand it over to Octopus Deploy. So it's not a super complex one, but something that we typically see out there in the real world. Now, when it comes to my actual build itself, what that workflow looks like, when I changed a few things. I said I wanted to change everything to run on Arm-based processors. I wanted my runners to do that. Thankfully, GitHub makes that super easy. They provide you a list of what you can do if you want to use their hosted runners. So I just picked one that used Arm, and I kind of was just off to the races when it's all said and done. So you'll see this comment appear multiple times. That wasn't an absolute step. I didn't have to do that, but that was something that I just wanted to do to gain that additional efficiency and better price to performance. Now, when it comes to the actual build, so I'm going to scroll down to my build. You can see as I'm doing that every single time that I wanted to run this on ARM. All I really needed to do is, because I was using this step, Docker build push action. Again, this speaks to the maturity of what's available within GitHub as well as within Octopus Deploy when it comes to building for x86 or ARM. All I needed to do is just add, I want to go to Linux/ARM64. That was it. And it just published everything automatically for me. So I was able to publish for both architectures, and then my Kubernetes cluster, it's running, because it's running on ARM, it's just going to automatically download the ARM version as opposed to the x86 version. Easy peasy. Now, when it comes to my Docker file, I did have to make two small tweaks. I had to add this, the platform, and then I also had to add this, and that was really it. I didn't have to change anything in the actual workflow within GitHub. It just kind of passed those in automatically for me. It's super easy to transition everything over. All right, so I'm going to jump over to Octopus Deploy to show you what this looks like. So if this is your first time seeing Octopus Deploy, this is the dashboard. This is what everyone sees when they first sign in to Octopus Deploy. On the left, I have my applications, and I can scroll down and I can see everything. And on the top, I can see my individual environments. So you'll notice that some applications, they just go to test and production, while others will go to dev tests and then production. And so this is doing a blue-green style deployment. And this also gives me a very high-level overview of the status of each of my deployments. So I can see these were successful, the last time I deployed, and so on and so forth. In addition to that, if something fails, this is what it would look like. So I could see that rather quickly, or if I had to cancel it for whatever reason, I was able to see that as well. Now let's see where I'm at with that build. So it should be finishing up fairly soon, and it'll be able to do that. But when it comes into the actual deployment itself, so I'm going to jump into this project that I have. And what we're going to see here is a little bit more in-depth view of the application. So I can see that I have this version that went to test but hasn't gone to production. And I can see the most recent versions. In addition to that, I can also see the process. So this is going to be my process that I'm going to use to deploy to my applications. Now, the nice thing about this is I really didn't have to change anything when it came to the actual deployment. I just said I want to deploy this container. I'm going to use a manifest file. My manifest files didn't have to change whatsoever because it just worked. And everything just started working, which was fantastic for me. On top of that, when it comes to the actual deployment targets themselves, let's go over here. And so how does it work when it comes to deploying to ARM? Well, I'm deploying to EKS. And so we install a very small agent on the EKS cluster called the Kubernetes agent. We have both an x86 version as well as an ARM version. And it just connects up to Octopus Deploy. There's nothing else, nothing fancy or anything I had to do with it. We provide you all the necessary steps to go ahead and do something like that. And just to show you that I'm not trying to pull the wool over your eyes, this is the cluster that I'll be deploying to. If I click on compute, then I can come through here and I can see the actual nodes that I want to be deploying to. If I click on the nodes, I can see that I'm running Amazon Linux 2023, and I can see the instance types is C8G. As we learned, when you see G, that means Graviton, so I'm doing that C8G large. So those are the nodes that I'm running on top of. All right, if I come back to my dashboard, I can now see that I have an application running and it's being deployed up to my test environment. I won't go ahead and deploy to production. I'm just going to wait for it to just deploy up to test for this. And you can see it's going to be running through all of the various steps. Again, I didn't have to change anything. I think I can't reiterate that enough. There wasn't a whole lot of stuff that I needed to change for this to work. If this is, again, your first time seeing Octopus Deploy, what we're seeing right now is the task log. And so this is providing very detailed information as to what's going on. I can see the logs. Now, typically, unless something's failed, you're not going to spend a tremendous amount of time looking through and watching this happen in real time. Most of the time, most people will see the task summary, uh, and they'll see various success messages, any sort of information that you need to know about, anything along those lines. But in addition to doing the deployments, one of the other things that we do when it comes to Kubernetes specifically is we can also see the health status of our applications. So if I were to click on this, I can see the status. Again, one of the powers of Kubernetes is all of this information is very easy to get. So I can pull back, what is the status of my application? Is it healthy? Is it unhealthy? Is it in sync? And so on and so forth. And again, I can't, I keep sound like a broken record, but I didn't have to change anything. This is just all automatically provided to you. We're very agnostic when it comes to actually running, and we're very agnostic to the actual like underlying architecture. And so we want to support ARM. I think it's a fantastic platform. Awesome. So that is all I have to say. I'm going to hand it over to Alexis and Eric, and they're going to talk a bit about how to migrate, because it was easy for me. It's probably not going to be as easy for everybody else because I had a pretty simplistic application. So they're going to help out with how you can leverage GitHub Copilot and the ARM MCP.
Excellent. Thank you, Bob.
Thank you.
Hey, folks. So, yes, what we're talking about, if there's a general theme for everything you're hearing today, it's how do you run services efficiently, essentially, is what we're going for. And we're talking about different chipsets, different hardware, different applications. We're going to get into all of this. But essentially, what you want, the goal we're going for is we want to take you from will this run on ARM to, okay, this just works, which was a great part of Bob's presentation a moment ago. So, at GitHub, the way we've been approaching this problem for the past couple years and introducing or trying to introduce new foundational tools to better assist you in this way. Copilot Coding Agent was a major milestone for us. This allows you to delegate tasks to Copilot directly, completing your objectives in parallel. What does that mean? How does that apply? Let's hop into it. That being said, this was just a foundational piece. Running processes in parallel is one area of the puzzle that we want to solve. One of the problems that every developer runs into working with AI is going to be centered around context. Why isn't this working? So, coming back, bringing our partners on this webinar into focus here, let's say you have your code hosted on GitHub, deployed with Octopus to AWS infrastructure. You're excited about the new Graviton options, but there's a question of, will my code be supported? What does the migration path look like? What's going to break, and what's the cost of getting from point A to point B? So this is where, going back to Copilot Coding Agent, you might assign a task to Copilot saying, make sure my code works on a specific ARM chipset. However, you might continuously have to go back and forth with Copilot, continuously providing feedback, additional context, which chipset, which coding patterns, which SDKs can be used, et cetera, et cetera. And this is where we took things a step further. Last year, we introduced something called Copilot Coding Agent Custom Agents. Essentially, it's one of the many ways GitHub is looking to address managing context. Custom agents are a way to define instructions, context, and tools available for Copilot. From a technical perspective, a custom agent is simply a markdown file where you can define a more specialized path for Copilot to process incoming tasks. For instance, you can create a custom agent whose focus is only on implementing functional coding patterns. Now, if you ask Copilot, create a hello world application, it will do so only in the patterns that you've described. Essentially, each time a task is assigned, you have a coding agent primed with specific knowledge and purpose around incoming jobs. As a result, you get higher quality output from Copilot with less compute. Rather, we're getting closer to the goal of it just works. Okay, bringing this full circle back into the scenario we described earlier, we did launch custom agents with a number of partners, such as Arm on this list here, who have provided their own instruction sets, MCP tooling, all with the aim of providing higher quality pull requests. The end state, the end goal of all of this is to really cross that bridge into, okay, I have a code base, maybe with even a home run would be a single Copilot coding agent task. We can pass this off to Copilot and know what changes we have to make, have those changes implemented, reviewed by the maintainers of the repo, and deployed to, in this case, AWS Graviton or any ARM chipset. There's a really great demo here with Arm's custom agent. And with that, I'm going to pass this off to my co-speaker here, Eric.
Thank you, Alexis, and thanks, team. This is it's really a pleasure to join you all and tell the story together with you. And Alexis, you really just said it best. We want to get to it just works when it comes to adopting ARM servers, adopting Graviton, all of those benefits that you heard about earlier. We want to unlock that and make it as easy as possible. And Bob demonstrated how it can be very easy, right? And in many applications, from web servers to database, will just work. But if you have complex software, complex deployments, maybe they're already multi-architecture, maybe they're multi-cloud. You need best-in-breed tools, as Bob was referring to earlier, which is why we're thrilled to be part of the Octopus Deploy ecosystem and have capabilities to deploy everywhere. And with GitHub, we're able to build, test, and deploy on ARM better than ever. And what was very clear is we need to lean in. It was clear, back in September when, GitHub announced everything they were doing for agentic at that time, and how that story has continued to evolve. It was very clear we as ARM need to lean in and support this specialization of delegated agent type workflows that Alexis is describing. And we're thrilled to be a part of that list of custom agents that launched at GitHub Universe. And we've been deploying our custom agent. And I think so far, we're really seeing wonderful opportunities that developers have to migrate their software to ARM as simply as possible. And this is all powered by an ARM MCP server under the hood. I want to tell you a little bit about that. We've designed this MCP server to, like any MCP server, be accessible across any agentic workflow, any agentic tool. But we really leaned into the developer experience that Alexis was describing, so that we could build right in to the developer's day-to-day build and test environment a capability to spin up an agent and handle various tasks commonly associated with migration, and to make all of the expertise that ARM has from our ecosystem and some of the other lower-level best-in-breed tools accessible to developers, but also to agents. And so we have three foundational pillars underneath our MCP server. One is this class of migration tools, things that will look at a container image and analyze it and look for dependencies or missing dependencies for the ARM architecture, or versions that could enhance the functionality of that image. And so tools like that, along with migrate ease and a few other low-level tools, can really help automatically identify the parts of your software that may have architecture-specific semantics or intrinsics, and move those right over to ARM automatically for you under the auspice of an agent delegated to do that migration task. Similarly, we have another pillar that is our knowledge pillar, where we have just decades of knowledge and in some of ARM's fantastic documentation from what we call the ARM, the Architecture Reference Manual, or any of our server class CPU designs, all of which many of which are used in servers everywhere and are utilized by the Graviton instances, the now 5 generations of Graviton instances that you heard about earlier. And so all of that really deep knowledge about the underlying CPU, the programming model, the architecture, all of that combined with really practical tutorials to do basic fundamental tasks that we offer in what we call our ARM learning paths, to dashboards of software's lists of software and databases of software that support the ARM architecture, along with the versioning of which versions support that, along with databases of intrinsics all of that knowledge is packaged up and unlocked through the MCP server to a developer or the agent. And that, combined with a few really carefully engineered prompts, can make our MCP server really, really useful for handling two really common tasks. And those tasks are going to grow over time as we continue to add to the functionality, as we add more tools and add more capability to our MCP server. But we started out with two really basic ones. First one just scans your code base, looks for clear places to make changes for the ARM architecture, and will make those changes for you. Or it'll suggest changes for you and provide you pull requests that have a lot of changes very well articulated and described, and then a human in the loop can just adopt those changes very easily. And you have a workflow that's very natural, so you could go through some of the steps that Bob mentioned earlier and start your deployment. As soon as you run into pitfalls and there's clear things that need to happen in your code base, you can employ our MCP server and take advantage of that under GitHub Copilot with a custom agent, our ARM migration assistant coding agent, and get that work automatically completed by the agents for you. And then the second prompt functionality that we've enabled is just scanning your container and making that container multi-architecture for you, addressing dependencies, etc. So just taking these really significant, standard, pretty meaty tasks sometimes of just scanning your code base, making architecture-specific changes, or taking your container and making it architecture, multi-architecture friendly. Those two things just happen out of the box with the MCP server. And so making this accessible, sorry, I accidentally muted. Making this accessible was very clearly the next step. I'm struggling to advance the slide. I apologize. Oh, thank you very much. So what I want to show you now is a little demonstration of how this MCP server operates as a custom agent under GitHub, under GitHub's Copilot framework. So we can just go ahead and switch over. Thank you. Okay, so the migration agent uses our MCP server to make all of this migration tasks easier. You just start by creating a new issue. It can be very generic, like migrate this repo to ARM. Use whatever tools in the MCP server you need. And you can give this very open-ended task, an assignment to a Copilot custom agent known as our ARM migration agent. This is available in their awesome coding agent repository. You assign this task, and you go ahead and leave and come back when the agent's finished. If you want, you can actually watch and see what's happening in the actions that you've generated for that. And you can see the MCP server get installed, make sure there's no issues with that. And then you can actually watch it go to work. You can see it use the different tools to perform your migration, depending on what those are. And you can kind of watch it in real time. Or alternatively, you can come back and when the agent's finished, you can view the open pull request and just check out what they've decided to do. And in this example, we're looking at a Python database that they migrated the processing pipeline to ARM. And we'll take a look at the PR here. They give you an overview, summary of the changes. You can see there were a number of package dependencies that they had to update. You can see that they made some backward compatibility. You can see some of the example usage, and then you can go in and see the actual specific changes that were done and look at everything and learn from what the agent did, review all the changed files in a very granular way. And then when you're ready, when you feel good, you can go ahead and commit the changes and start to test them and start to, with Octopus Deploy, go ahead and see and make sure that your deployment works well and takes advantage of running on Graviton. And it's really just that simple in many cases. Obviously, very complex cases can result in PRs that might give you some advice instead of, and maybe example changes that you might have to try and iterate on. But all of the context switching for learning the ARM architecture and going into a TRM or an ARM, or going through a tutorial on how to spin up a Graviton instance, or all those things, all of that's encapsulated underneath our MCP server. So you can go from not just doing some of the porting tasks to maybe if you have, a native if you have a native ARM runner, you can start doing some build and test right there with the ARM runner, or you can bring a self-hosted runner and start setting up actions for doing test and validation, and have the agent go to work creating some of those tests and test plans for you as well. So there's just a diversity of tasks that you can apply this agent to today. We'd love to hear more about it. If you're able to advance the slide or come back to the slide and advance the slide, I'll just quickly summarize what this agent's able to do, right? It's built for developers by developers that do a lot of work migrating software to support the ARM architecture and open sourcing and upstreaming that software. So we built this MCP server to take advantage of all of that knowledge and tools. And we've released the tools that we've used to do this work to enable the entire ARM ecosystem. And powering it by this MCP server gives you this really flexible framework to use in any environment, but especially under GitHub Copilot's custom agent framework, and let you make and take all the AI-driven optimization suggestions automatically for you by a delegated agent, and get really close to that. It just works in an end-to-end automated way that really is the nirvana that Alexis talked about. Next slide, please. And if you're interested in learning more about the MCP server and our integration and getting started right away, you can just go to our developer.arm.com website, and you can navigate to the URL here, or you can kind of browse your way over to the ARM MCP server or search for it on our website. And you'll come to this page and you'll get a complete overview of how to use this, what's included, where the MCP server lives in Docker toolkit, where it is in the MCP registry on GitHub, and how to use it in different environments, and really how to get started in GitHub's custom agent framework. And with that, I believe that's pretty much the rest of my portion.
Yeah.
Back over to you, Bob.
Thank you so much, Eric. Thank you so much, Alexis, on that. That's fantastic. Yeah, so just kind of key points that I just want to wrap up a little bit. Before I do that, if you do have questions, please start sending them through. We'd love to answer any questions that are out there. This veritable who's who of brain trust when it comes to ARM, when it comes to AWS, when it comes to GitHub and Octopus. So take advantage when you have the chance. But yes, when it comes to modern software delivery pipelines, they require the best in breed tooling for increased security and compliance. That's just kind of a known thing. But in best breed tools, we're talking about GitHub, we're talking about Octopus Deploy, we're talking about AWS, and we're talking about AWS Graviton. That's part of that entire tech stack. You can't just be thinking about an individual tool. ARM-based processors offer numerous performance and cost benefits, as we saw, for AWS workloads. And then migrating modern applications from x86 to ARM requires minimal changes. And even if they do, we have the tools that are in place now with the MCP server that ARM has put out there that integrates with tools such as GitHub Copilot. So those are all of these things that make it super easy to migrate over and start running on ARM. And so it kind of feels a little silly when you don't have that chance to be able to do something like that. But yes, if there are any questions, we'd be happy to answer that. If not, we're happy to continue on with the day. But I'll just leave it open for any questions. As you're watching this, I guess I'll open this up to Alexis and to Eric and to Miranda. Did you have any questions about anything that you saw? I'd be kind of curious to see or hear. Or any thoughts that you wanted to share before we sign off?
Yeah, actually, no. You mentioned, Bob, that some of this was new to you. Any really pleasant surprises or surprising friction points that you went through in setting all of this up?
Yeah, I would say probably the hardest friction point that I kind of ran into, to be completely honest, was setting up the EKS cluster. It's more along the lines of I didn't want to use the command line. I didn't want to actually do it the right way. I was trying to do click ops, which isn't the right way to do it. But once I set everything up, it was actually super easy. I didn't have to run into any big hurdles or anything like that. What made me really happy also was the fact that once I changed over to using the ARM-based runners on GitHub, again, I didn't have to really change anything. I mean, we had the tools, everything just sort of just worked. And I think that was kind of I don't have to worry about this anymore. And I think that speaks to the maturity that we hear about with ARM. I mean, if you asked me 6-7 years ago, do you want to migrate your applications to ARM? I'm like, I have to think about all these third-party dependencies. Will my pipeline support this? Will this work? Will this work? And today, it's a nothing burger, to be completely honest, for a lot of applications.
That is music to my ears, right? As an ARM person. So that's really great to hear. And it's great to see, firsthand is really great to see. I had one question. On that list of partners with the custom agents, I noticed Octopus Deploy also leaned in like ARM did early, and it's wonderful to see. And I appreciate it's early days. We are learning how agentic frameworks are going to get consumed. I'm really curious. I would love to get some agent-to-agent collaboration going, even more so. And I'm just thinking, like, if we did this wonderful like development pipeline and maybe even a CI/CD pipeline where we're, deploying, realizing we need to migrate, take advantage of our migration agent, migrate, maybe have some try deploying again, have some issues with your agent, maybe to diagnose what's happening, perhaps, or contact our agent, and we kind of solve this problem together and the block and tackle the complexity with our specialized components. That idea sounds really cool to me. I'm curious what your thoughts on that are, Bob.
Yeah, I mean, again, it's early days with this particular extension that's out there, and we have our own MCP server as well that sits out there as well. So what really I think what we'd want to do is just kind of probably get the two groups together. So we have an AI foundations team that's focused in on this, building that stuff out and improving it, everything along those lines, and really thinking through the use cases and how we want to have these things work together. Because I can't speak to the ARM MCP server. I can only speak to the Octopus MCP server. But under the covers, our MCP server is a wrapper around our Octopus Deploy API. So at the end of the day, it's just it's another interface into our application. So we have CLI, we have the UI, and now we have agentic, and they all go into the API in some form or fashion.
Yeah, it's really cool. It's really cool to see, like, just putting the capability out there. And for those of you out there, we'd love to hear your thoughts on how you're employing agentic frameworks, and if you're using these custom agents already today, and if what you're hearing, you're getting some ideas on how what might be useful to you across the MCP servers we're talking about and the user experience we're trying to provide out there. We'd love to hear from you. So please reach out, and we'd love to work with you and help you with not just a migration workflow, right, but a CI/CD pipeline of the future, the infrastructure of the future that you need to continuously deploy your software reliably and wherever it might have to run, whatever cloud, whatever hybrid environment. Yeah, cool.
Yeah, 100%. I can see in the future what the deployment process would probably look like is maybe after you finish your coding and type one single command, and AWS, GitHub, and Octopus will just take care of the rest, and you don't have to do anything about it. How cool!
Yeah, that's really I guess that's really the dream. Is, I mean, at the end of the day, I mean, the CI/CD pipeline should be kind of behind the scenes. You shouldn't really have to think about it. I check in a change, it just does the thing. My rule of thumb is a cup of coffee. I should be able to get away, get a cup of coffee, come back. By the time I come back, everything's done. I have something ready to test. I have something maybe instant, even up into production, depending on the time of day and what I'm trying to do. But it should be a no stress thing. That's really the goal behind it. But it should also be compliant. You shouldn't just be YOLOing it and hoping for the best.
Totally. Yeah, really looking forward to see that future and how things are wrapping up. I think the speed of the generative AI evolvement in the software engineered world is really, wow. We're in an era of revolution, I say that way.
Very interesting times, to say the least. So awesome. Well, thank you so much, Alexis. Thank you so much, Eric. Thank you so much, Miranda. Really appreciate your time. Thank you, everyone, for joining us today. I haven't seen any questions come through. That's fine. There's probably a lot to take in, a lot of information that was thrown at you today. So we're just give you 12 minutes. Oh, here we just got one that popped up. Can we use ARM architecture from the outset for generative AI solutions? And is there a cost savings compared to the FinOps area?
I'm happy to start, and maybe Miranda, you can tell me a little bit more from the AWS perspective. Yeah, I mean, I would say yes. From the onset for generative AI solutions, yeah, there's an enormous amount of on CPU capability in a Graviton server, and there's lots of AI workloads already being deployed today. Generative AI workloads being deployed today, and these might not be the largest frontier models, right? But they think of like 20 billion parameter models doing highly capable things, specialized things, especially if you look at like an area like FinOps, where there might be some really domain specific things, and a general purpose model might not be the best solution. but rather a 20 billion parameter model that is trained on all of the compliance rules you might have, or all the regulatory principles and practices you might have and need to comply with. And you might need to do something where you're delivering continuous compliance for your clients in your solution, and then continuously having to update that software to ensure you're meeting all of the stringent requirements. I think those are areas where Arm can help with the development of that solution, and the workflow we described can help with the development and the maintenance of that solution that would be deployed on Arm. And that's kind of my perspective from the breadth that I see, but perhaps you may have some more from the AWS perspective, more real world cases, because I know there's an enormous amount of deployment on Graviton.
Yep. So essentially, think of Graviton or Arm-based chips are simply a one single component that's powering all of your cloud-based workloads. So in the FinOps area, you have analytical, you have a large database, you have intensive computational requirements of there. So all those workloads, as long as it's running in the cloud, you can move or test things in Arm-based instances. It's as easy as what we showed up today, just to change what kind of instance you're looking at. Traditionally, you might be selecting M5 extra large, but next time, maybe you can try M8G extra large. And then here you get the cost benefits. And you can also have a look at the pricing comparison between your current workload versus what if we move everything into Arm-based Graviton instances of the. In general speaking, we advise very conservative number is around 20% of the cost savings straight away you can achieve by simply select another type of instance in EC2 panel. Hope that answers your question, Mario.
Awesome. Yeah, that was a good question. That was a great question. Yeah. I think the big takeaway that I've learned from anything from this webinar, especially preparing for it, is at the end of the day, it's just it is another option when I'm setting up my EKS clusters, my AWS Lambdas, or ECS or RDS or DynamoDB or whatever the case may be. But it's just a more efficient, better price to performance. But it's just a different thing I'm selecting from the drop-down list and a different filter. So that's great, and that's how we want it to be. Awesome. Well, thank you so much, everyone, for your time. I greatly appreciate it. I will give you a few minutes back of your day, and have a great one.
Really grateful to you, Bob and team. It was excellent to be here today. Thanks. Have a great day. Cheers,
Thank
everybody.
you.
Thanks, everyone. Thanks.
Thank you, folks.